Welcome back, guys. Today we are discussing about Python exercises from EDX. Today we'll especially talk about full perceptron algorithm. In this step, we will implement full perceptron algorithm. We'll be given same feature matrix and labels array as we were given in complete hinge loss. This is complete hinge loss, and we'll be given same matrix and label array as in complete hinge loss. We will also given maximum number of times that we should iterate through the feature matrix before terminating the algorithm. Initially, we should set the theta and theta now to 0. Here is a perceptron function that we need to implement. Let's read through the comments so that we fully understand the function itself. It runs a full perceptron algorithm on a given set of data, runs t iteration through the data set, and there is no need to worry about stopping early. Please use the previously implemented function when applicable. Do not copy and paste code from previous part. Arguments, feature matrix, a numpy matrix describing given data. Each row represents a single data point. Labels, a numpy array where kth element of the array is correct classification of kth row of feature matrix T. An integer indicating how many times perceptron algorithm should iterate through the feature matrix. This function returns a tuple, where the first element is a numpy array with value theta, the unique classification parameter after t iterations through the feature matrix, and the second element is a real number with the value of theta null. Theta not the offset classification parameter after t iteration through the feature matrix. Now we have to fill out a code here. Now let's move into writing the code into this piece of function. First of all, we need to define the current theta. Current theta equal to np dot zeros Now second line is current theta naught, and we can assign that to 0 as well. That's a 0 2. Next step is to go through the iterate through this data set t number of times, and that's why we have a loop given here, and each iteration we will iterate in different order. So for that reason we have a second inner loop where it shuffles the ordering randomly for each iteration. Third step is to look at the data and do a single step update for each piece of data or line of data. And for that, we need to use a perceptron single step update. And for that, we need to go here and just grab this function and put it single perceptron update, and it inputs feature matrix, current theta, and current theta naught. Remember he said about the feature matrix, this one. So we can use the same thing from the complete hinge loss. and put it here. So current theta naught. This is the first. So it takes these parameters and computes the theta and theta naught for a particular piece of data. Let's look at the next step. As a next step, let's look at a perception single step update. What it returns? Let's see. It is returning a tuple here, right? Therefore, what we need to do when something returns a tuple, how do we digest that, or how do we assign that into a variable? For that, we need to assign that into a different variable. We need to index it once we get the return value, and therefore we need to do indexing here, which is 0. And second, we'll take the second part of a tuple and index that as 1. Next step is to individually assign that to different variable using comma. Let's do comma here, comma, and currencies are not. Now we're assigning them back to a current theta and current theta not. Once this is complete, it goes to next piece of data and does the same update if it's required, and does this for t number of iterations. Once that's done, it should return a tuple with this two pieces of information to the outside world. That is current theta and theta not as a tuple itself. We'll package them as a tuple and send that to outside world. Okay, we have done this function. Let's review what we discussed today. We discussed about creating a full perception algorithm that passes through the data t number of times in different order, and to implement that full perception algorithm, we use perception single step update function. Thank you so much and see you later.